Okay, in this video we're going to look at solving systems of equations with elimination. So let's look at a first example. 3x plus y equals 11 and 5x minus y equals 5. So again, we're solving a system of equations, which means we are looking for the point where these two lines intersect. Now again, we know that lines don't really take the nice easy form that we were used to earlier in the year, the y equals mx plus b form, but that doesn't mean these two are still lines, and it doesn't mean that these two lines don't intersect. So we're developing different strategies to look at different forms of equations and different forms of systems, so we're able to solve any system of equations. Now we use elimination. Elimination is a technique we use when both of our equations are written in standard form. And standard form is when your x's and y's are together and your x's and your y's equal a single total. Okay, your x and y are on the same side of the equation and a single number is on the right side. So both of these, we have our x's and our y's equal a total, our x's and our y's equal a total. These are both in standard form, so we're going to use elimination. Now the goal of elimination is to see how we can combine the equations so that we eliminate one of the variables. So sometimes we combine the equations by adding, sometimes we combine them by subtracting, sometimes we have to multiply or manipulate one of the equations to make one of the variables eliminate. But again, the whole goal is to combine the equations so that we could eliminate or get rid of one of our variables. So let's look at this example. 3x plus y equals 11 and 5x minus y equals 5. So the very first thing we always try and do is we just think, if we simply combine these equations by adding, will anything eliminate? Well, I notice I have a positive y and a negative y. Okay, so I focus my attention on my y's, and I see that if I just add these two equations together, I notice a positive y and a negative y are just going to zero out. They're just going to cancel out. So I'm going to add these two equations together. That's how I'm going to combine my equations in this system, because these cancel out. So 3x plus 5x equals 8x. 11 plus 5 equals 16. And now I have a very simple equation. 8x equals 16 divided by 8, and I get x equals 2. Okay, so that was very easy. I just noticed I have a positive y and a negative y, so they're going to cancel out by adding these two equations. So I add everything. 3x plus 5x is 8x. 11 plus 5 was 16. So 8x equals 16 means x equals 2. That's great. So our x is 2. Now again, just like any other system of equations we solve, we have to also figure out what our y is. Okay, we know figure 2, they're going to have the same number of tiles. Now we want to know how many tiles will both of our equations have. So we look back at our two original equations. We have 3x plus y equals 11. So we want to know what is y when x equals 2. So we're going to substitute 2 in for x. Okay, 3 times 2 plus y equals 11. 3 times 2 is 6. So 6 plus y equals 11 simply means y equals 5, because 6 plus 5 equals 11. So we want to check the other equation to make sure we did the right work. So we have 5x minus y equals 5. Substitute 2 in for x. 5 times 2 minus y equals 5. 5 times 2 is 10. Okay, I know 10 minus 5 equals 5, which means y equals 5. Okay, and that makes us happy. Both our y's are 5, so when x equals 2, both our y's equal 5, so these two lines will intersect at the point 2, 5. All right, let's look at another example. Negative 2x plus 11y equals negative 14. And 2x minus 5y equals negative 10. So I notice both these equations are in standard form, which is why we're going to use the elimination method. Our x's and our y's equal a total for both of our equations. So I think, how can I combine my equations to eliminate one of my variables? So I look for something. I notice I have a negative 2x in my first equation and a positive 2x in my second equation. Well, I know by simply adding these two equations, these x's will eliminate. So I'm going to add these two equations. Okay, what if I just combine these equations by adding? I know my negative 2x and my positive 2x. Negative 2x plus 2x zeroes out. So I want to add these two equations together. That's how I could combine these two equations to eliminate one of my variables. So I'd add everything. 11y plus negative 5y is 6y. Negative 14 plus negative 10 is negative 24. We just got to be careful what we're doing, but we just take our time and realize that we're doing 11y plus negative 5y, which is 6y. Negative 14 plus negative 10 is negative 24. Now it's very simple. Y equals negative 4. We just divide both sides by 6. So just like everything else, we got to figure out, well, what is our x in both of our equations? So we know y equals negative 4, so we have to go back and figure out, well, what is our x in both of our equations? So we do negative 2x plus 11y equals negative 14. We know that y equals negative 4, so we're going to substitute negative 4 in for y, so we could find what x has to equal. 11 times negative 4 is negative 44. I'm going to add 44 to both sides, so I have negative 2x equals 30. I'm going to divide by negative 2, so x equals negative 15. So my first equation, when x equals negative 15, y equals negative 4. So I got to figure out, well, what is my x in my second equation? So I have 2x minus 5y equals negative 10. Substitute negative 4 in for my y. 2x minus 5 times negative 4 equals negative 10. 2x, negative 5 times negative 4 is positive 20, equals negative 10. Subtract 20 from both sides, 2x equals negative 30. Divide by 2, x equals negative 15. That's exactly what I wanted. Okay, when x equals negative 15 in both of my equations, y equals negative 4. So these two lines will intersect at the point negative 15, negative 4. Okay, again, this is a very systematic approach. We just want to get used to this and practice it a lot so we get good at it when we see it on quizzes or tests. So why don't you try these two examples on your own. So we have 4x plus 3y equals 10. 5x minus 3y equals negative 1. And the other example, negative x plus y equals negative 5, and x minus 4y equals 11. So press pause, try these two examples, and press play when you're ready to check your work. Okay, so again, we see a system of equations. We notice both equations are in standard form, so we're going to use eliminations. We ask ourselves, how can we combine these two equations so that one of our variables eliminate? Well, I know in my first equation I have a positive 3y, and in my second equation I have a negative 3y. So these two are going to cancel out if I simply add my two equations together, because I know a 3y and a negative 3y cancel out. 3y plus negative 3y is 0. That's what we want. We want to eliminate one of our variables. That's our whole goal. So we add the rest. 4x plus 5x is 9x. That equals 10 plus negative 1, which is 9. So if 9x equals 9, that means x equals 1. So we got to figure out what was our y. So we substitute 1 in for x in both of our equations. So we do 4 times 1 plus 3y equals 10. So we get 4 plus 3y equals 10. Subtract 4 from both sides. 3y equals 6, which means y equals 2. Okay, so for our first rule, when x equals 1, y equals 2. So we got to figure out if x is 1 in our second rule, we better hope y also equals 2. That makes us know that we did it correct. So 1 in for x again. 5 times 1 minus 3y equals negative 1. 5 times 1 is 5. Minus 3y equals negative 1. Subtract 5 from both sides. Negative 3y equals negative 6. Divide by negative 3. Y equals 2. So these two lines are going to intersect at the point 1, 2. Okay, this equation. Again, we know it is standard form, so we're going to use elimination. What do I have to do? How do I have to combine these two equations? Well, I notice I have a positive x and a negative x, so these two are going to cancel out if I simply add the two equations together. Okay, negative x plus positive x eliminates, is what we wanted. They zero out. Y plus negative 4y is negative 3y. We're just careful with our integer operations. Y plus negative 4y is negative 3y, and negative 5 plus 11 is positive 6, which means y equals negative 2, because we divide both sides by negative 3. So again, we got to substitute negative 2 back into both of our equations to figure out what's x. So negative x plus negative 2 equals negative 5. I got to add 2 to both sides, get rid of this negative 2, so I have negative x equals negative 3, which means x equals 3. Okay, and my second equation, x minus 4y equals 11. I know my y equals negative 2, so I have x minus 4 times negative 2 equals 11. Negative 4 times negative 2 is plus 8 equals 11. So that means x equals 3, exactly what we wanted when x equals 3 in both of our equations, y equals negative 2. So these two lines intersect at the point 3, negative 2. Okay, great. Now let's look at our next set of examples. Again, we're doing a lot of examples so we get very good and very comfortable solving systems of equations. So, 7x plus 11y equals 40. 7x plus y equals 10. So we notice again, these are both in standard form. So we're going to use elimination to solve it. So we need to figure out how can we combine these two equations so that one of my variables eliminates. Well, in the previous 4 examples, all we did was add the equations. But if we added the equations here, we'd get 14x plus 12y equals 50. And that does us no good. Okay, we need to make sure we eliminate our variables when we combine our equations. This is what we want to do. If we don't eliminate a variable, then we didn't do what we needed to do. We didn't do our work correctly. So we got to figure out how else can we combine these two equations. We don't always add, sometimes we subtract. So I notice I have 7x on my first equation, 7x in my second equation. Well, I know 7x minus 7x cancels out, it's 0, so I want to subtract these two equations. That's how I could eliminate these two, or my x variables. Okay, if I subtract these two equations, because 7x minus 7x is 0. And your whole goal when you combine your equations is to eliminate a variable, so you better do what you need to do to make that happen. And then we just subtract everything else. 11y minus y is 10y. That equals 40 minus 10 is 30. We just take our time to do the operation we said we're going to do. 11y minus y is 10y. 40 minus 10 is 30. 10y equals 30 means y equals 3. Okay, nothing hard about solving that equation. And just like always, we got to substitute back in to figure out what our x has to be. So y equals 30, so we're going to do 7x plus 11 times 3. I'm just going to skip a step here and say that's 33 equals 40. Subtract 33 from both sides. Get 7x equals 7. Divide by 7 and get x equals 1. So my first equation, when x equals 1, y equals 3. So we better hope we get the same thing in our second equation, 7x plus y equals 10. So again, we substitute 3 in for y. 7x plus 3 equals 10. Subtract 3 from both sides. 7x equals 7. Divide by 7 and get x equals 1 as well. These two lines intersect at the point 1, 3. And we know we did it right because we got that in both equations. Okay, next one. 3x plus 8y equals 13, and negative 2x plus 8y equals 18. Again, we notice that these two equations are both in standard form, so we're going to use eliminations. We got to figure out how can we combine these two equations so that one of our variables eliminates. Okay, if we add them, we know we have 3x plus negative 2x is 1x, 8y and 8y is 16y, so we'd have x plus 16y equals 31. Adding these two equations would do us no good because our variables wouldn't eliminate. But we notice that if we have an 8y in our first equation, we have another 8y, positive 8y in our second equation. We know that 8y minus 8y is 0, so we want to subtract these two equations to eliminate our y's. Again, our whole goal is to eliminate one of our variables. So if we subtract 8y minus 8y, the y's are gone. It's exactly what we want to happen, so we're going to subtract everything else. Okay, subtraction gets rid of these, so we have to do 3x minus negative 2x. Again, we're just taking the extra time to be careful with our signs. 3x minus negative 2x is 5x, because minus and negative is really plus, and 13 minus 18 is negative 5. And just take the extra 2 seconds to make sure you're doing your adding and subtracting of your integers correctly. 13 minus 18 is negative 5, so 5x equals negative 5, means x equals negative 1, so we just divide both sides by 5. Now we substitute negative 1 back in for our x's. We have our first rule, 3x plus 8y equals 13. So we're going to do 3 times negative 1, which is negative 3, plus 8y equals 13. Add 3 to both sides. 8y equals 16. Divide both sides by 8 and get y equals 2. Our second rule, just to make sure we also get y equals 2, we have negative 2x plus 8y equals 18. So we're going to substitute negative 1 in for x, because that's what x equals. Negative 2 times negative 1 is positive 2, plus 8y equals 18. Subtract 2 from both sides. 8y equals 16. Divide by 8. Also get y equals 2. So these two lines intersect at the point negative 1, 2. Okay, great. So your turn. You're going to get 2 examples. You're going to try them on your own. And you're going to press pause to check your work. Or do your work and press play to check it. So we have 5x plus 12y equals 130. 5x plus 10y equals 110. And negative 3x plus 2y equals 10. And x plus 2y equals 10. Okay, so let's go through these. Okay, we want to know how can we eliminate one of our variables. Well, I see I have a positive 5x and a positive 5x. I know 5x minus 5x is 0. That'll eliminate my x's, so I want to subtract these two equations. So I subtract everything else. 12y minus 10y is 2y. 130 minus 110 is 20. So that means y equals 10. Substitute back to find our x's. Our first equation, 5x plus 12y equals 130. Substitute 10 in for y, so we have 5x. 12 times 10 is 120, equals 130. Subtract 120 from each side, so 5x equals 10, which means x equals 2. Okay, in our second equation, 5x plus 10y equals 110. Y equals 10, so we have 5x plus 10 times 10 is 100, equals 110. Okay, subtract 100 from both sides. 5x equals 10. Divide and we get x equals 2. So these two lines intersect at the point 210. Okay, our right equation. We want to figure out what do we have to do, how do we have to combine these two equations to eliminate one of my variables. So I realized 2y minus 2y. If I subtract my two equations, my y's cancel out. So I'm going to subtract everything else. Negative 3x minus x is negative 4x. 10 minus 10 is 0, so negative 4x equals 0 simply means x equals 0. We just divide by negative 4. So now we substitute back in to figure out our y. So we have negative 3x plus 2y equals 10. Substitute 0 in for x. Negative 3 times 0 is 0. So we're left with 2y equals 10, which means y equals 5. In my second equation, x plus 2y equals 10. 0 in for x, so x is 0, so we're just left with 2y equals 10. Means y equals 5, so these two lines intersect at the point 0, 5. Great. Okay, and our last set of examples where things aren't as nice and neat. But again, it's important we take the time to practice and make sure we're comfortable with all the possible cases so we're ready for them on quizzes and tests. Okay, let's say we have 5x minus 2y equals 0, and 2x plus y equals 9. So again, we notice this system. They're both in standard form. Both our x's and our y's equal a total in both of our equations. So we need to use elimination. Now what's different about this one is none of our variables match up. None of them are going to eliminate if we simply add these two equations together. If we combine them, we get 7x and minus y equals 9. We still have both of our variables if we just add these two equations together. We'll still have both of our variables if we just subtract these two equations together, because nothing's going to cancel out as is. Okay, so we want to be able to deal with this? Okay, what can we do? Well, we're also allowed to manipulate our equations. We're allowed to multiply every single number in either one of our equations or both of our equations by any number we want. Okay, so, and we do that so that we can make one of our variables match up. We want to make one of our variables eliminate. So we do whatever we need to do so that when we do combine our equations, one of our variables are going to eliminate. So I notice I could very easily get a positive 2y here by multiplying this second equation by 2. Because I notice I need a positive 2y to cancel out to eliminate with my negative 2y. If this was positive 2y, that'd be nice. We just combine them and they'd be gone. So let's just make this a positive 2y. And we do that by multiplying every single number in this second equation by 2. Okay, so our first equation stays the same, so we're just going to rewrite it, 5x minus 2y equals 0. And now, in order to make our y's be able to be canceled out, we had to multiply every single term in the second equation by 2, which we're allowed to do. We're allowed to multiply in our equation. So 2 times 2x is 4x, 2 times y is 2y, and 2 times 9, we got to remember to multiply everything in our second equation, equals 18. Now this is very easy. I notice we have a positive 2y and a negative 2y. These will cancel out if I simply add these two equations together. Okay, we have to be smart enough to know that do we add or subtract? Well, we add our equations when they're going to cancel out as is. Negative 2y and a positive 2y are just going to cancel out if we simply combine them. So that's why we want to add these equations together. So let's add these two equations together. 5x plus 4x is 9x. Our negative 2y plus positive 2y cancels out. And 0 plus 18 is 18. So 9x equals 18 means x equals 2. Great. Now, like always, we still got to figure out what was our y. Now, as you see, we have a whole lot of equations here. Okay, we don't want to get confused. Okay, we just want to figure out in our original two equations, when x equals 2, what's our y? So we go back to our original two equations. Okay, our 5x minus 2y equals 0, and our 2x plus y equals 9. Okay, so when x equals 2, we're doing 5 times 2, which is 10. So we have 10 minus 2y equals 0. I'm going to subtract 10 from both sides. Negative 2y equals negative 10. Divide by negative 2 and get y equals 5. Now we're going to go back to my other original equation, my 2x plus y equals 9. Now it really doesn't matter if you choose this one or after you multiply by 2, but the smarter choice is to choose the original one because we're dealing with smaller numbers. Before we multiply by 2, these numbers are a lot smaller. So we substitute 2 in for x. So 2 times 2 is 4. 4 plus y equals 9. Well, it is obvious that y equals 5 as well. Subtract 4 from both sides. So these two lines intersect at the point 2, 5. And the only thing difference here was at the beginning we realized that nothing's going to cancel out as is. If we add them together, we're still going to have both variables. If we subtract these two equations, we're still going to have both variables. So we realized we had to multiply our second equation by 2 so that when we do combine them, one of our variables cancel out. So again, our whole goal is to make sure one of our variables cancel out. If that doesn't happen, then we didn't do the work correctly. We got to try something else. Okay, our next example. 2a plus 5b equals 9, and 6a plus 7b equals 3. So first thing, we have a system of equations. Our variables equal a total. Our a's and our b's equal a total in both of our equations. That means they're both in standard form, so we're going to use elimination. Okay, we're not afraid of the different variables. Okay, we know we solve them the same way. Just because they're not x and y doesn't mean we do anything different. So we look for anything that's going to cancel out. Well, I see that adding is going to give me 8a plus 12b. I still have both my variables. Subtracting is not going to do me any good. I'm still going to have both my variables. So I got to think, what can I do? How can I manipulate my equations? What do I have to multiply one of my equations or both of my equations by so that I could add or subtract these two equations? Or I could combine these equations so that one of my variables cancels out. Well, I notice that if this was a 6a, I could easily subtract these two equations. Okay, so I think, how could I turn this 2a into a 6a? Well, I can multiply every single term in my first equation by 3. Okay, because if this was a 6a, I'd be able to subtract them. So let's just make it a 6a, and we do that by multiplying everything by 3. Okay, I know 2a times 3 would give me that 6a, which is why I know I have to multiply every single term in this first equation by 3. So let's do that. 3 times 2a is 6a, 3 times 5b is 15b, and 3 times 9 is 27. Okay, and my second equation stays the same. I didn't do anything to that. It's just 6a plus 7b equals 3. Now these two equations are exactly the same as these two. I just multiply my first equation by 3, so I could turn it into a form that we can eliminate. Now we have a 6a and a 6a. Now I see if I just subtract these two equations, my a's will eliminate, because again our whole goal is to eliminate one of our variables. 6a minus 6a is gone. It's what we wanted to do. 15b minus 7b is 8b. 27 minus 3 is 24. Divide by 8, and we get b equals 3. Like always, we got to figure out what's our other variable. If b is 3, what's our a? So we go back to the original two equations. So we have 2a plus 5b equals 9. Well, I know b equals 3, so I have 2a plus 5 times 3 is 15 equals 9. Subtract 15 from both sides, so 2a equals negative 6. Divide by 2 and get a equals negative 3. My other equation, 6a plus 7b equals 3. Okay, I know my b is 3, so I'm going to substitute 3 in for b. So I have 6a plus 7 times 3 is 21 equals 3. Subtract 21 from both sides. So 6a equals negative 18. Divide by 6, a equals negative 3. So my answer, a equals negative 3, b equals positive 3. And that's it. So again, this is a very systematic process. All these problems look very similar when we solve them, but it's important that we take the time to practice so that we get very, very good at solving system of equations using elimination. So the difference about these two is they just had this extra step. We realized, well, wait, we have to multiply one of our equations by something first before we combine them, because nothing cancels out as is. So why don't you try these two last examples. So we have 3x plus 2y equals 1, and 2x minus 10y equals 46. Our next example, a plus s equals 42, and 5a plus 3s equals 146. So press pause, try these two problems, and press play when you're ready to check your work. Again, our first equation, standard form, so we think elimination. Nothing's going to eliminate by simply combining these equations by adding or subtracting, because none of our coefficients really match up. So we think, well, what can I multiply? How do I make one of my coefficients match up? Well, I notice I could easily make this 2y a 10y. I can multiply this 2y by something to get a 10y so that it could eliminate with this negative 10y. So I'm going to multiply every single term in my first equation by 5. Because again, if this was a positive 10y, it would cancel out with this negative 10y. And the reason why I chose my y's is because 2 can be multiplied by something to get to 10, whereas the 2x and the 3x can't really be multiplied by a whole number. It's why we went to the y's, because 2y times 5 will get us to 10y very easily. So 5 times 3x is 15x, 5 times 2y is 10y, and 5 times 1, we just remember to multiply everything, is 5. Our second equation stays the same. 2x minus 10y equals 46. So I did that so my y's will cancel out. 10y and negative 10y will cancel out when I add these two equations together. 15x plus 2x is 17x. 5 plus 46 is 51. 51 divided by 17 means x equals 3. Like always, got to figure out what our y is. We go back to the two original equations. 2x or 3x plus 2y equals 1. 3 times 3 is 9. So 9 plus 2y equals 1. Subtract 9 from both sides. 2y equals negative 8. Divide by 2. Y equals negative 4. Second equation, 2x minus 10y equals 46. Substitute 3 in for x again. 2 times 3 is 6. Minus 10y equals 46. Subtract 6 from both sides. Negative 10y equals 40. Divide by negative 10 and get y equals negative 4. All right, sorry for the pause. We just want to look at our last example. Again, we notice nothing's going to cancel if we simply add or subtract these two equations. So we think, what do we have to do? Now, in this one, we're left with a couple of options. Okay, I can make this a 5a if I multiply by 5. I could also make this s 3s if I multiply by 3. I'm going to multiply by 3 just because it's a smaller number. Whenever you have the choice like this, choose the smaller number to multiply by to make it a little bit easier for yourself. So I'm going to multiply this first equation by 3. 3 times a is 3a, 3 times s is 3s, and 3 times 42 is 126. So we have 3a plus 3s equals 126. Again, we multiply by 3 so that our s's will be able to cancel out. In the second equation, 5a plus 3s equals 146. So I notice if I subtract these two equations together, my s's will cancel out. So I want to combine these two equations with subtraction. 3a minus 5a is negative 2a. 126 minus 146 is negative 20. Again, we're just careful to do the operation we said we're going to do. So negative 2a equals negative 20, so a equals 10. We just divide both sides by negative 2. Okay, a equals 10. Now we got to figure out what's s. So our first equation, a plus s equals 42. So we substitute 10 in for a. So we have 10 plus s equals 42. So s equals 32. We just subtract 10 from both sides. And our second equation, 5a plus 3s equals 146. Substitute 10 in for a. So 5 times 10 is 50. Plus 3s equals 146. Subtract 50 from both sides. So we have 3s equals 96. Divide by 3 and get s equals 32. So our answer is a equals 10 and s equals 32. Okay, that's how we solve systems of equations using elimination. And if you need more examples, refer back to your textbook or some of the online resources.